Okay, hi everyone. So today we will continue um, after that. So we will continue today from character or trace of element. So first of all, write down what do you mean by character. This character is also known as your trace. Okay, character or trace of the element. So so this is also represented by what? Chi. Okay, and character or trace means what? So this is basically your sum of elements, sum of elements of main diagonal. Okay, sum of elements of main diagonal. So if I write down the identity matrix, so what is your identity matrix? 1 0 0 0 1 0, and last one is your 0 0 1. So basically if I write down this chi e, okay, so sum along the diagonal, you have to sum up the elements along the diagonal. So 1 plus 1 plus 1, this is equal to what? Equal to 3. Okay, so character means what? Character means you have to sum up the elements along the diagonal, that's it. Okay, so next write down that character character of identity, character of identity is called, character of identity is called dimension. Character of identity is called dimension. So basically I can write down the chi e is equal to 1. If you are getting one value, so that means it represents 1D. If you are getting two values, so it represents your 2D. And if you are getting 3, so that means it represents 3D value, 3D. Okay, so character of identity is called dimension. Now similarly, suppose you have C2Z operator and I am operating this C2Z operator on XYZ Cartesian coordinates. So if you operate this C2Z operator on XYZ Cartesian coordinates, so what will happen? The Z will remain fixed, Z will not change, but the other two will change. This X and Y, they are changing. So what I am getting? Minus X, minus Y and Z. So basically I can write down like this: minus X plus 0 into Y plus 0 into Z. Similarly I can write down 0 into X minus Y plus 0 into Z, and last I have 0x plus 0y plus z. So if I take common of x, y, z, what I will get? I will get minus 1 0 0. Next you have 0 minus 1 0, and lastly you will have 0 0 1. So if I take common of this x, y, z, so what I am getting? I am getting this matrix. So basically I can write down that C2Z, so that means the Z value is not changing, but X and Y will change. So what I am getting? Minus 1 0 0 0 minus 1 0, and lastly I have 0 0 1. So this is your C2Z matrix. Okay, this is your C2Z matrix. Now suppose I want to find out the character of this table chi C2Z. So if I add diagonally, so what I am getting? Minus 1 plus 1. So they are cancelling each other. What I am getting? Minus 1. So chi C2Z, that is actually equal to what? Minus 1. So similarly I can find out for C2x. For C2x, what will be the matrix for C2x? So if I rotating along x axis, so that means along x axis it will not change. So you can just write down 1 0 0, but along y and z it will change. Okay, along y and z it will change. Okay, so if I write down now chi C2x, so that will be equal to what? 1 minus 1 minus 1. So that cancels out. I am getting only minus 1. Okay, I can write down for C2y also, that C2y is equal to what? So C2y means along y axis it will not change, so I will get minus 1 0 0. Next you will get 0 1 0, and last you will get 0 0 minus 1. So if I find out this chi value for C2y, so what I am getting, minus 1 plus 1 minus 1. So this cancels out, I am getting only minus 1. So chi C2x, chi C2y, all the value, if you find out the character for this C2x, C2y or C2z, you will get minus 1. Okay. Now next comes your plane. So suppose I am talking about sigma xz plane. Okay, this plane, this operator I am operating on xyz Cartesian coordinates. So for plane, see, we have mentioned two planes xz, right? So that means x and z will remain fixed, they will not change, only y will be negative. Okay, y will change. So what I will get, so we will get, if you operate this operator on xyz, so you will get x minus y z, you will get this matrix. So if I have to represent it, what I will get, so x plus 0 into y plus 0 into z. Next I have 0 into x minus y plus 0 into z. Next I have 0 into x plus 0 into y plus z. So now if I take common of all these things, so what I am getting, 1 0 0. Here also I am getting 0 minus 1 0. Here also I am getting 0 0 1. Okay, so this is basically your what, sigma xz matrix. So I can write down clearly here that sigma xz matrix is what, 1 0 0 0 minus 1 0, and last you have 0 0 1. So this is your sigma xz matrix. Similarly I can write down for sigma xy. Okay, sigma xy, so tell me, so xy will not change, so write down 1 0 0. Y will also not change, 0 1 0, but z will change, so it will be 0 0 minus 1. Sigma xz, sigma xy, and another one is your sigma yz. So that means along yz it will not change, but x will change, so you will get minus 1 0 0, then you will get 0 1 0, and lastly you will get 0 0 1. So if I find out the identity, okay, sorry, character or trace of chi of what, sigma xz, so that means along diagonal you have to add along the diagonal. So what I am getting, 1 minus 1 plus 1, so you are getting only 1. If I find out chi value for sigma xy plane, so along diagonal you just add along diagonal. So what I am getting, 1 plus 1 minus 1, so again I am getting 1. If I add diagonally along sigma yz, chi sigma yz, so what I am getting, minus 1 plus 1 plus 1, so again I am getting 1. Okay, so that is the way you can find out the character or trace for each and every operator. Now suppose I have inversion center. This operator I am operating on x y z. So basically what you will get, inversion means what, you will get, so you will get minus x minus y minus z. Okay, and if I write down here, so what I will get, minus 1 0 0. Okay, 0 minus 1 0, and lastly you will get 0 0 minus 1. So this is the matrix you will get. And basically if I find out the character for this inversion center, so along diagonal you just add along the diagonal. So what you will get, minus 1 minus 1 minus 1 is equal to what, minus 3. Okay, now basically for any here we are finding out for C2. If you see for C2 we are finding, but for C3 C4 C6 that we do not know, right? So basically for Cn axis, how to find out for other n value, suppose we know for C2, but what will be the value for C3, what will be the value for C4, that we do not know really, right? So we have a formula. So for Cn, you can put any n value here for C2, C3, C4, C5, C6, C7, C8, anything you can do. Okay, and this Cn is basically what? This is your what? Axis of symmetry, right? Which operation? It is your axis of symmetry. Axis of symmetry. Okay, so this Cn is equal to what? This Cn is equal to what? It will be equal to cos theta, then you will have sin theta 0, cos theta sin theta 0. Here you will get minus sin theta cos theta 0, and lastly you will get 0 0 1. Okay, so what I am getting? Cos theta sin theta 0. Next you will get minus sin theta cos theta 0, and lastly I will get 0 0 1. So this formula you can remember. Now you can put the value, you will get the thing. Okay, suppose here I am putting for C2. Okay, I am showing you how to find out. So n value, how we get the n value? N is equal to what? 360 degree divided by theta, right? So if I am putting here n value 2, so that means that theta value is what? 180 degree, right? What is the formula? N is equal to 360 degree by theta. So if I am putting n value 2 here, this n value I am putting here 2, so that means this theta value will be what? 180. So if I put all the value, so what I will get? Here I will get cos 180 degree. Okay, next will be your sine 180 degree. Here you will get 0. Next row you will get minus sine 180 degree. Okay, here you will get also cos 180 degree 0. Okay, and lastly I will get 0 0 1. Okay, so now you just put the value cos 180 degree. So cos 180 degree value will be your minus 1, sin 180 degree is 0 0, minus sin 180 degree again 0, cos 180 degree again it will be minus 1 0, and then you will get 0 0 1. So by this formula also you can find out the C2 matrix. Okay, so by this formula you can also find out the C2 matrix, and from this formula you can see I can also find out the character or trace, because if I add or if I sum up along the diagonal, okay, if I sum up along the diagonal, so what I can write down, that chi Cn, this is equal to what? 2 cos theta plus 1. So I can write down for chi C2, it will be what? 2 cos 180 degree, 2 cos 180 degree plus 1, right? So cos 180 degree means what? What is the value of cos 180 degree? Minus 1. So minus 2 plus 1, you are getting minus 1 value for chi C2. Okay, so you no need to add also. If you put simply in this formula you will get, or if you are interested to add you can do it. Okay, you will get the same answer by both the way. Okay, now suppose I am finding for C3. Okay, for C3 what will be the matrix? So that I have to find out. So C3 means theta value will be what? Theta value will be your 120. So write down here that cos 120 degree, then it will be your sine 120 degree, then it will be 0. Next will be what? Minus sine 120 degree. Okay, then it will be your cos 120 degree 0, and lastly you will get 0 0 1. Okay, so if I put the value now, so for cos 120 degree, that will be what? Minus half. Sin 120 degree will be what? Root over 3 by 2, and this is your 0. Now minus sin 120 degree, that will be what? Minus root over 3 by 2. Cos 120 degree will be what? Cos 120 degree will be your minus half, again 0, and lastly you have 0 0 1, right? 0 0 1. So this is the thing you are getting. Now for chi C3 you can directly put in the formula, or you can add diagonally. If I add diagonally, what I am getting? Minus half plus 1, that is equal to 0. Or you can put in the formula 2 cos theta plus 1, right? So you write down 2 cos 120 degree plus 1. So cos 120 degree means what? Minus half plus 1. So what I am getting? Minus 1 plus 1 is equal to 0. Okay, so basically this chi C3 value is equal to 0. Fine. So what I am getting, that character of identical element, that will be equal to 3. Character of inversion center, that will be equal to minus 3. Okay, character of C2 axis, that will be equal to minus 1. Character of sigma value, that will be equal to 1. And character of C3, that will be equal to 0. Okay, you can find out for C4 axis also. Okay, so find out C4. So if I put n value 4, so that means the theta value will be what? N is equal to 360 by n is equal to what? 360 degree divided by theta. So how can I get n value 4? If you put theta value is equal to 90, right? So put the value. So here you will get cos 90 degree, then what? Sin 90 degree, then 0. Then next will be what? Minus sin 90 degree, cos 90 degree, 0. And lastly you will get 0, 0, 1. Okay, so cos 90 means what? Cos 90 means 0, sin 90 means 1, and this is 0. Minus sin 90 means minus 1, cos 90 means 0, 0, and that one also will be 0, 0, 1. Okay, so basically if I write down the character table chi C4, that will be what? 0 plus 0 plus 1, so it is equal to 1. Okay, or you can find out 2 cos 90 plus 1, you will also get the same thing. So like this way you can find out for any Cn axis, you can find it out. Okay, for any Cn axis you can find out the uh, matrix element. Okay, now next comes improper axis of symmetry. So next is our improper axis. So improper axis means what? So improper axis means, suppose you have Sn axis. Okay, so here also you have one formula. So here we have this formula, that cos theta, then you have sin theta, then you have 0. Next you have minus sin theta, cos theta, 0, and lastly we have 0, 0, minus 1. Okay, so this is your improper axis. Sn is equal to what? Cos theta sin theta 0, minus sin theta cos theta 0, and 0, 0, minus 1. So if I write down this chi value, so chi Sn, so if you add diagonally, what will be the character? So you will get what? 2 cos theta minus 1. So it is very easy to remember. Chi Cn, that is what? That is your 2 cos theta plus 1, and chi Sn, that is your 2 cos theta minus 1. Okay, these are the only formulas we have. 2 cos theta plus 1 for Cn, and for Sn it will be 2 cos theta minus 1. Okay, that is the thing. So now suppose I want to find out for S2. Okay, for S2 what will be the matrix? So n value 2, so that means the theta value will be 180 degree. So put the value here, cos 180 degree. Then you will get sin 180 degree. Okay, 0. Next you will have minus sin 180 degree. Then what I have? Cos 180 degree, 0. And lastly you will get 0, 0, what? 0, 0, minus 1. Not 0, 0, 1, 0, 0, minus 1. So now put the value. So cos 180 value is your minus 1, sin 180 value is 0, and this value is 0. Minus sin 180, that value will be 0. Cos 180 will be minus 1, and it will be 0. and last you have 0 0 minus 1. So did I did some mistake? So minus 1, yeah, minus 1, fine. So basically if you see this minus 1 minus 1 minus 1 0 0 0 minus 1 0 and 0 0 minus 1, that is equivalent to what? If I go above, you can see here we have already did this. See, this one is what inversion center, right? So this one is actually equal to your inversion center. So if you this s2 is actually becoming equal to your inversion center. Yesterday I have written that s2 is equal to I have written directly, so that is the proof. Okay, if you put in the formula, you will also get the same thing. So s2 is equal to what? I. And if you want to find out the chi s2 value, so you can directly put in the formula, or you can sum up, that is minus 3, or you can do by the formula also, that 2 cos theta. So here it will be 2 cos 180 degree minus 1. So put the value, so it will be 2 into minus 1, so you are getting minus 3. Okay, similarly for s3 also you can find out for s3. Okay, so for s3 it will be what? It will be your cos 120 degree, then it will be what? Sine 120 degree, then it will be 0. Next will be your minus sine 120 degree, it will be your cos 120 degree 0, and last one will be 0 0 minus 1. Now tell me the value for 120 degree. So for cos 120 degree, the value will be what? Minus half, right? For cos 120 degree, the value is minus 1, minus half. Sin 120 degree, it will be what? It will be your root over of 3 by 2, it is 0. Now minus sin 120 degree, so that will be minus 3 by 2. Then cos 120 degree, again it will be minus half, 0, and last you have 0 0 minus 1. So if I want to find out the character, so chi is 3, so you have to add diagonally, so minus half minus half minus 1, so basically I am getting minus 2. Or I can write down, you can put in the formula that 2 cos 120 degree, then what? Minus 1. So basically you have 2 into minus half minus 1. So what I am getting? I am getting minus 2. Fine. So these are the things you have to remember, and these are the ways you can find out for Cn axis and for Sn axis. Okay, these are the things. Fine. Fine. So now I'm giving one you a question. Okay, basically that will be a theoretical type of question, that is not your need gate question, but yeah, that will clear your idea. So suppose you have the Cartesian coordinates x y z. Okay, this is the Cartesian coordinates, you have x y z. So first of all, number 1, write down that rotation along z axis. Okay, rotation along z axis. And number 2, write down that reflection in yz plane. So that you have to do. Okay, that is the question. So you have xyz Cartesian coordinates, so first of all you have to rotate along z axis, and number 2 you have to do reflection in yz plane. So this thing you have to do, and then they are asking that find matrix of representing two-step transformation. Matrix of representing two step two step transformation. Okay, two step transformation. Okay, so that is the thing. So first of all, yeah, try by yourself. Okay, try for 1 minute, then I will do. Okay, if you see the recording also, you just first of all try by yourself. So you have this xyz Cartesian coordinates. First of all, you have to rotate along z axis, and then you have to do reflection in yz plane, and then tell me what is the matrix you are getting after operating these two operations. Okay, do it by yourself. Okay, so done. Done. So what I have to do, so first of all you have to do rotation along z axis, and next step will be your reflection in yz plane, right? So basically what I have to do, I can write down like this, that sigma yz, okay, and that is cross what, c to z. So first of all you have to operate this c to z axis on this xyz Cartesian coordinate. So if I rotate along this c to z axis, so what I will get, if I rotate along this z axis, what I will get, so I will get minus x minus y z. Okay, minus x minus y z. And next is what, so if you operate c to z operator on xyz coordinates, so you are getting minus x minus y z. Now if I operate this sigma yz operator on this, so what I will get, yz will not change but x will change, right? Yz, because you are operating sigma yz, so yz will not change but x will change. So what I am getting, x minus y z, x minus y z, right? And that is actually what, so from xyz to x minus yz, you can get in a single step. That is what? That is your sigma xz, right? So basically I can correlate that sigma xz is equal to what? Which matrix you are getting? Which matrix you are getting? See, x minus y z. So that means you can write down 1 0 0, next will be your 0 minus 1 0, and the last one will be 0 0 1. So this is your sigma xz. Okay, this is your sigma xz, and that is the matrix now you are getting. Okay, or you can do similarly, you can do like this in your normal mathematics. So sigma yz into c2z, right? So sigma yz means what is the matrix? How can I represent sigma yz matrix? So sigma yz means x will change. So minus 1 0 0, then it will be 0 1 0, last one will be 0 0 1. This is your sigma yz matrix, right? Into what? c2z. So c2z means z will not change, xy will change. So minus 1 0 0 0 minus 1 0, last one will be 0 0 1. So if you now multiply, so how to multiply? Like this and like this, right? You have to multiply like this. So this is your along the period, you can see. Okay, and this is along the column, right? So first of all move horizontally, then vertically. So multiply now. So minus 1 into minus 1, that will be 1, right? Then what you have? 0 into 0, that will be 0, and then again 0 plus 0, so you will get 0 for here. Similarly now this first horizontal with this second column. So if I multiply minus 1 into 0, that will be 0, 0 into minus 1, that will be also 0, and 0 into 0, that will be also 0. Now first horizontally and third column, so that will be also 0. I am not showing, but you can do minus 1 into 0, 0 into 0, 0 into 1. Second thing, this column with this period with this, first of all this column, so you will get here 0. Then if you multiply, so here you will get minus 1, here you will get 0. Okay, and last will be this, so here also you will get 0. Okay, then 0 and 1 into 1, so you will get 1 here. So basically what I am getting 1 0 0 0 minus 1 0 0 0 1. So this is the matrix you are getting, which is what? Which is your sigma xz. Xz means what? Y will change, right? So yeah, both the things you can do in our chemistry rules, or you can do your simple like matrix multiplication, your normal 11 12 mathematics, you can use also that. Okay, so in both the ways you will get the same answer. Okay, okay, fine. So next we have different things. So now next we have representation of a group. Okay, so first of all give the heading that representation of a group. Okay, so representation of a group. Now this representation of a group, this is basically of two types. Okay, this is basically of two types. So one is your what? Reducible representation. Okay, reducible representation, and another one is your irreducible representation. Okay, so reducible representation, and another one is your irreducible representation. So in reducible representation means what? So write down one line that reducible representation means can be reduced which can be reduced which can be reduced to lower dimension which can be reduced to lower dimension. Okay, and in irreducible representation, that is what, so here you can write down that cannot be reduced cannot be reduced cannot be reduced to representation cannot be reduced to representation of lower dimension. Okay, so we have two types. One is your reducible representation, another one is your irreducible representation. So in reducible representation means what, which can be reduced to lower dimension, and irreducible representation means that cannot be reduced to representation of lower dimension. Okay, so these are the general definition of these two. So now next write down that how to derive reducible representation. Okay, because we have to derive it, right? So derive how to derive reducible representation. How to derive reducible representation. Okay, so first point, write down that can be derived with respect to some basis. Okay, so can be derived with respect to some basis.
যেটা দেখতে এসেছিল আইআইটিয়া বিরাট ব্যাপার তো মাতি বলছে সরকারি চাকরি করালে ওইটাই স্টপ করো না তো মাতি বলছে সরকারি
রেকর্ডিং হচ্ছে, শোনা যাবে, পরে বলছি। So how to derive this reducible representation? So can be derived with respect to some basis. Okay, with respect to some basis. And second is your 3n coordinate. Okay, 3n coordinate. Okay, coordinate 3n coordinate. Okay, along this we can do xyz axis. Okay, xyz axis. We have bond angles. So these are the parameters we have to take care of: bond angles and bond length. So what are the things we have? So how to derive reducible representation? So first of all, it can be derived with respect to some basis. Okay, and second thing, you can derive, these are the parameters you can use: 3n coordinate you can use x y z axis, you can use bond angles, we can use bond length also. Okay, so one by one we will see all the things. Okay, basically that with respect to some basis, that we will not see now. So basically we will see in which basis we are actually trying to figure it out. So first of all, give a heading here that derivation of reducible representation. Derivation of reducible representation. Okay, on the basis of on the basis of x, y, z axis. Okay, so derivation of reducible representation on the basis of x, y, z axis. Okay, x, y, z axis. Fine. So suppose I have, first of all we are talking about on very simple molecule, water molecule. So suppose you have water molecule. So water molecule exists like this. Okay, now along this oxygen atom, okay, we are drawing the three axes. So this is your x axis, this will be your y axis, and this one is your z axis. Okay, so x axis, y axis, and z axis. Okay, and what are the elements we have present here? So we have E. Okay, then we have C2Z. Okay, next you have sigma xz, and the last one will be your sigma yz. So these are the elements present in water molecule that you already know, right? Now keep in mind one thing, that if no change in direction, okay, no change in direction, no change in direction, so that time you can use plus 1. No change in direction, you can use plus 1. Okay, and another will be what? Another one will be like this, change in direction. Okay, change in direction, so that will be minus 1. So if no change, that time you can use plus 1. If it is changing, that time you will get minus 1. Okay, now see, so first of all write down all the elements here. So E is present here, then what you have, then you have C2Z, next you have sigma xz, and last you have sigma yz. So these are the elements, symmetry elements we have. Now first of all write down here that effect on x axis, effect on x axis, effect on x axis. So if I operate this E operator in this water molecule, x axis will not change its position, right? If I operate E operator on this water molecule, so x axis, x, y, z, anything will not change their position, so that one you will get 1. Okay, if I operate C2Z, okay, C2Z operation on this x axis, so what will happen? Suppose C2Z, so that means along z axis you are rotating the molecule 180 degree, right? See, C2Z means what? Along this z axis you are rotating the molecule 180 degree. If you rotate by 180 degree, so that means this x will come now to this side. Initially it is in the right hand side, after rotation it will be in the left hand side. So that means what? That is your minus 1. Next you have sigma xz. So sigma xz means which plane? Sigma xz means this plane, right? Sigma xz means this plane they are talking about. So if I place this sigma xz plane, and suppose this is a mirror, okay, so you are keeping this mirror in front of the molecule. So if you keep this mirror, xz mirror, in front of the molecule, x axis will not change its position, right? So no change, so that means it will be 1. Now sigma yz, so yz means this mirror, yz means this mirror. Okay, I am drawing with different colors, so it will be easy to visualize. Okay, this mirror, I am talking about this mirror. So if I place this mirror, okay, so that means what? This x axis is in the right hand side. If I see in the mirror, it will be in the left hand side. So they are changing their positions, right? So basically if they are changing their position, so that means it will be your minus 1. So like that you have to check, you have to operate the operations, and then you have to check that x axis they are changing their positions or not. Now similarly you can do effect on which axis? Y axis you can do. So for E operator it will not change, it will be 1. Now suppose you have C2Z, so along z axis I am rotating it, so that time definitely y axis will change its position, right? So it will be minus 1. Now see sigma xz, so if I apply here sigma xz, so that means this plane, okay, this plane, and this side you have, front side you have y, and you are keeping one mirror here. So in the mirror what you can see? you can see the y-axis here in the opposite direction, so that means it is changing its position, so it will be -1. But if you keep this plane sigma yz plane, so see, that time it will not change its position, right? If you take this sigma yz plane, that time y-axis is not changing its position, so it will be 1. Now last one will be your what, z-axis, so e will be 1. Now C2Z, if you rotate along z-axis, z-axis will not change its position, so it will be 1. Sigma xz, if you keep this sigma xz plane, again z-axis will not change its position. If you take this one sigma yz plane, that time also it is not changing its position. So basically you are getting what, you are getting all the things like this. So if I now add up, what I am getting, 1 plus 1 plus 1 3, here -1, so here you will get -1, here also you will get -1, and here also you will get here 1 minus 1 plus 1, right? Yeah, sorry, so it will be your plus 1, okay, and here if I add again you will get plus 1. So basically this is the overall effect you are getting, okay, fine. So like that you can find out the reducible representation for any point group. So I can write down that C2V, okay, this is the point group you have, okay. So what are the elements we have? E, then you have C2Z, next you have sigma xz, and then you have sigma yz. And this reducible representation, what are the values you are getting for reducible representation? 3, here you have -1, then you have 1 1, okay. So this is the reducible representation we have, okay, this is the reducible representation we have, reducible representation we have, and this notation is actually known as your Bethe notation, okay, this notation is actually known as your Bethe notation. So what do we have? We have this this is the reducible representation of your C2B point group, okay, that we will use later, okay, because in NET and GATE exam they basically gives this table, sometimes you have to find it out, okay, so that is the thing, okay. So like that you can find out the reducible representation for any point group, okay, for any point group, fine. Now next, write down that derivation of reducible representation, derivation of reducible representation on the basis of 3n coordinates, on the basis of 3n coordinates, okay. So suppose you have n is equal to what, here n is equal to number of atoms, okay, n is equal to number of atoms, okay. So 3n coordinates, so that means what, 3n's means how many coordinates you are getting here, so 3 into 3, suppose I have water molecule, suppose I am taking water molecule, so that means you have 3 atoms here, so 3 into 3, right, so that is equal to 9, so that means what, you will get 9 coordinate systems, okay, 9 coordinate systems. So if n number of atoms you have, you will have 9 coordinate systems, okay, 9 coordinate systems. Now for each atom I can actually keep this one x1, okay, for this one y1, and for here you will get z1. Similarly for oxygen you can do, this is your x2, here you will get y2, here you will get z2, here also you will get x3, then you will get y3, and last you will get z3. Okay, so these are the like axis you are getting based on that. Now here what we have to do, we have to do for each and every atom. Okay, so we will apply, like for water molecule, what are the symmetry elements we have present, that you already know. So what are the symmetry elements we have, that we will operate on each and every atom. So first of all we are operating this identical operator in where, so I am writing here, so this is what, x1 y1 z1, this is for their first hydrogen atom. Next you have x2 y2 z2, this is for your oxygen atom, and last one will be x3 y3 z3. So if I operate identical operator on this axis, what I will get, so I will get this thing, x1 y1 z1, here also you will get x2 y2 z2, next you will get x3 y3 z3. Okay, so now I have to draw it. So for x1 you will get like this, 1 0 0, then you have y1, so it will be 0 1 0, for z1 it will be 0 0 1. Now see, in this axis or in this region you have no x2, right? So it will be 0 0 0 0 0 0, because 9 coordinate system it is, right? So 9 coordinate system you have to see, and x3 y3 z3, that is also not available here, so it will be again, it will be 0 0 0 0 0 0 0 0 0. Now x2 y2 z2, so here also you will get x2 y2 z2, right? So for x1 you have no x1 or x3 present in this horizontal row. In this row you have no x1 and x3, so for x1 you just keep 0 0 0 0 0 0 0 0 0. You have x2 y2 z2, so you just write down 1 0 0, then you will have 0 1 0, then you will have 0 0 1, and for x3 y3 z3 you will have this. Okay, now x3 y3 z3, so for x1 you will get no, nothing. Similarly for x2 you will have nothing. Now x3 y3 z3, so here you will get this. Okay, so this is the whole matrix representation for your identical, if you operate identical operator on this water molecule along your 3n coordinate system. Okay, along your, on the basis of your 3n coordinates you will get this one. Okay, now similarly I can, okay, now another thing I forgot. So if I try to find out the character for this identical element, so you have to add diagonally. Okay, so if you add diagonally, so 3 6 9, okay, the value will be 9. If you add diagonally, you just add all the ones, you will get this value. Fine. Next you have what, next you have C2Z. Okay, C2Z. So again I am applying here, so what I have, so x1 y1 z1, next you have what, x2 y2 z2, and last what you have, x3 y3 z3. So if I operate this, if I operate this operator along this 3n coordinate system, so first of all what you will get, along z axis I am rotating, so x and y will change, right? So I am giving one thing, see, so suppose this is your water molecule, so I am drawing it again here. So this is your x1 system, this is your x3 system, and this is your x2 system, right? Now I am rotating this molecule along z axis. So if I rotate this molecule along z axis 180 degree, what will happen? X3 will come in this position, X3 will come in this position, and X1 will come to this position, right? They are interchanging their positions. X1 and X3 hydrogen, they are interchanging their positions. So when they are interchanging their positions, so basically you have to write down here that minus X3, okay, then minus y3, and last will be your z3. X2 is not changing their positions, right? Oxygen is not changing its position, so it will be minus x2 minus y2, then you will have z2. X3 is changing its position, so it will be what? Minus x1 minus y1 and z1. Okay, this is the thing you have. Now if I write it down in this your whole matrix table, so minus x3 minus y3 z3, right? So no x1 no x2, so keep 0 here. For your x1 and x2 keep 0. So this is your for x1. For x2 also you just keep 0, x2 y2 z2, this one. And now for x3, minus x3, so minus 1 0 0, minus y3, so 0 minus 1 0, and for z3 it will be 0 0 1. Okay, now minus x2 minus y2 z2, so for x1 it will be again 0 0 0 0 0 0 0 0 0. This is for your x1. For x2 you can write down minus 1 0 0, y2 will be 0 minus 1 0, z2 will be 0 0 1, and for x3 you have nothing, so that means again you will get this thing, again you will get this thing. For x1 y1 z1, so for x1 you will get what? Minus 1 0 0, y1 you will get 0 minus 1 0, and z1 you will get 0 0 1. For x2 you will get this, okay, and for x3 you will get this. Okay, so this is the whole matrix we are getting for C2Z. And if I find out the character chi C2Z, so you have to add diagonally. So diagonally means like this, you have to add along this diagonally. Okay, so if you add you will get what? Minus 3. Okay, sorry, not minus 3, minus 1 plus 1, right? Okay, sorry, so minus 1 minus 1 plus 1, that will be equal to minus 1. Okay, so chi C2Z will be your minus 1. Now similarly I can operate sigma xz on this whole coordinate system. So x1 y1 z1, next you have what? X2 y2 z2, and lastly I have x3 y3 z3. So this is your sigma xz. So if I operate this sigma xz operator on this 3n coordinate system or 9 coordinate system, so that means the y will change. Now keep in mind xz you are applying, so that means this plane, xz means this plane you are applying, right? So you have this water molecule, let me erase it first of all. So xz means what? Sorry, xz plane means what? So this is your x-axis, okay, this is your x-axis and this is your z-axis. So this plane we are talking about, this plane. Okay, so if I keep this plane in front of the molecule, suppose I am keeping this plane in front of the molecule, x1 x3 x1 x3, they are not changing their positions. Okay, if I keep this xz plane in front of this molecule, they are not changing their positions, right? So basically I can write down here that if you operate this sigma xz, only y will be minus. So you just write down like this, that x1 minus y1 z1, here you will get x2 minus y2, then you will have z2, and here you will get x3 minus y3 z3. Okay, so now if I write down the matrix, so here you will get 1 0 0. For minus 1 y1 you will get 0 minus 1 0, and for z1 you will get 0 0 1. No x2, no x3, so you just write down here only this. Now x2 y2 z2, so here you have no x1, so keep like this, write down only this. So x2 means what? 1 0 0. y2 means what? 0 minus 1 0. z2 means what? 0 0 1. Now here also you will get, for x3 portion you are getting only 0. Now x3, so here for x1 you will get 0. For x1 you are getting 0. For x2 also you are getting 0. Okay, for x2 also you are getting 0. Now for x3 you will get what? 1 0 0 minus y3, so 0 minus 1 0, and z3, so that means 0 0 1 0 0 1. So this is the whole matrix we have. This one is the whole matrix we have. So if I have to find out now the character for this sigma xz, so chi of sigma xz, so you just add along the diagonal. So what I have? 1 minus 1 plus 1, then again you have plus 1 minus 1 plus 1, then again you have plus 1 minus 1 plus 1. So this cancels, this cancels, this cancels. So what I am getting? 1 plus 1 plus 1, so it is equal to what? 3. So chi of sigma xz, this value is becoming 3. Okay, similarly you can find out for your sigma yz plane also. Okay, so sigma yz for this whole coordinates. So what I have? x1 y1 z1, next you have x2 y2 z2, and lastly I have x3 y3 and z3, right? Now you just see that yz planes means this is your x-axis, this is your y-axis, and this is your z-axis, right? So yz plane means basically we are talking about this plane, right? We are talking about this plane. So suppose I have water molecule here. Okay, I have water molecule. This is your x1 system, this is your x2 system, and this is your x3 system. Now you are keeping one plane here. Okay, this plane we are talking about. So if I keep this plane here, so that means this x1 and this is x3. Okay, this x1 and x3, they will again change their positions. Okay, if I keep this yz plane, that time these hydrogens, they will interchange their positions. So that means again you have to write down here that sigma yz, it will be what? Minus x3. Okay, then y3 z3. Now see, x2 is not changing its position, oxygen is not changing its position, so you just write down minus x2. Okay, then it will be y2 z2, and at last you will get minus x1 y1 z1 minus x1 y1 z1. Okay, so again you can write down the whole matrix table like that only. Okay, so x3 means no x1 x2, so you just keep 0 here. Okay, this one for your x1. For x2 you can also keep like this. Okay, for x3 it will be minus 1 0 0. For y3 it will be 0 1 0, and for z3 it will be 0 0 1. Now minus x2 y2 z2, so no x1, so you just keep here 0 0 0 0 0 0 0 0 0. Now minus x2 y2 z2, so that will be what? Minus 1 0 0. Y2 will be what? 0 1 0, and z2 will be 0 0 1. No x3 y3 z3, so keep it like this. Keep it like this. Next you have minus x1, so it will be minus 1 0 0. Y1 will be 1 0. Z1 you have, so 0 0 1. No x2 y x2 x3, so it will be 0 0 0 0 0 0. Here also you have 0 0 0. Here you have also 0 0 0 0 0 0 0 0 0. So this is the thing, this is the whole matrix for your sigma yz. Now if I have to find out the chi value for your sigma yz, so that means you just add diagonally what you are getting, minus 1 plus 1 plus 1, so you are getting only plus 1. Okay, this is the character, okay, character of this. Fine. So basically if you have only 1D, okay, if you have 1D, because I have written on this already that you have E C2Z, okay, then you have sigma xz, then you have sigma yz, okay. So the reducible representation for 1D, for 1D it will be what? 3 minus 1 1 1, okay, this is for 1D system. Okay, but suppose you have 3n coordinate system, suppose you have 3n coordinate system, that time you can see what are the values you are getting. So for 3n coordinate system, E value you are getting 9, C2Z value you are getting minus 1, sigma xz value we are getting 3, and sigma yz value we are getting 1. So basically for 3n coordinate system, for 3n coordinate system, that time the reducible representation table, okay, this table, so for 3n system the reducible representation table is now becoming what? 9 minus 1 3 1. So this is for your 3n system, 3n coordinate system, okay, this is for your 3n coordinate system, and this is along your xyz axis, so that means this is for your this is for your 1D system, okay, this one for your 1D system, okay, and this one for your 3n coordinate system, so that means this is for your 3D system, okay, fine. So that's it for today, okay, just see up to that what we have done today, okay. So initially we are doing these things, okay, how to find out the character or trace, so you just have to add diagonally. Now for any cn axis we have a formula, okay, because we have to find out the matrix. So for any cn axis we have this formula for matrix representation, you just follow it, you will get for c2 c3 c4 c5 c6, any value you will get. For chi c2 character you have to put the value in this formula, 2 cos theta plus 1. For Sn axis again you have improper axis of symmetry, you have this formula for the matrix representation, and for characters you will get this 2 cos theta minus 1. Next you have next you have this representation of a group. So we have two types of representation, reducible representation, and another one is your irreducible representation. So how to find out the reducible representation? We have to take help from some basis. What are the bases we have to use? We can use 3n coordinate system, x y z axis, bond angles, bond length, we can take them. But here basically we are doing from your x y z axis and 3n coordinate system. So first of all I am doing by x y z axis. Here I have shown you how to find out the C2V, like this whole table, reducible representation table for C2V. But when we are doing this 3n coordinate system, so that times you have to operate like this, and here we are getting this table, okay, this table we are getting for your 3n coordinate system, okay. So that's it for today. We will meet in the next class, and yeah, in the next class we will see some examples, suppose for water, ammonia, methane, okay. We'll see some molecules, how to use this character table now, okay. Okay, that's it for today. Bye. Okay, thank you.